In this video, I will show you how to evaluate the derivative of an inverse function. Here's the formula, but it's pretty complex, so I recommend that rather than thinking of this as a formula, it's better to think of it as a process. So I've taken this formula and I have unpacked it into these 3 steps. For the next few problems, we need to evaluate the derivative of f inverse at a value of x equals a. For problem number 1, function f is 5 minus 2x to the third power, and the a value at which we will evaluate is 7. So here's step 1. We are supposed to evaluate the derivative of f inverse at a, but we start with simply f inverse at a. We need to find this. So I'm going to put x here as a placeholder, but this implies that the original function f at x will equal a, because that's how inverses work. See how I'm swapping the a value and the x value as I change from the inverse function to the original function? That's how the original function and the inverse function are related. So I'm going to use this version to solve for x and sort of plug that back in right here. So f of x is equal to a means that I have 5 minus 2x to the third power is equal to 7. We should be able to solve this. Let's subtract 5 from both sides. We get negative 2x to the third power is equal to 2. Dividing both sides by negative 2, we get x to the third power is equal to negative 1. Taking the cube root of both sides, we have x is equal to negative 1. So I'm going to take this and substitute it back in right here. So I'm just going to erase this x, and I'm going to put negative 1 in its place. So that is step 1 of my 3-step process. Step 2 is we're going to find the derivative of function f and evaluate it at the value that we just found in step 1. So if I'm evaluating the derivative, obviously I need to find the derivative first. So let's come over here and do that. So we need to find f prime. So here's the original function. The derivative of a constant is 0, so I write nothing. And now I'm using the power rule, so I'm going to get negative 6x squared. So here's the derivative. And now I need to evaluate this at negative 1. So that'll be negative 6 times negative 1 squared, which is really just negative 6 times positive 1, which is negative 6. And that is step 2. Step 3 is super easy, because step 3 is the final answer. We are supposed to find the derivative of the inverse function at a, but here's the secret. All right, if I want to do the inverse function derivative at a, that's just going to be the reciprocal of what we got in step 2. So I'm going to get negative 1/6, and that is the final answer. That's my 3-step process. Problem number 2. In the back of your mind, always remember we are trying to find the derivative of f inverse at a. We will do that using my 3-step process. Step 1 is to just find f inverse at a. And I'm going to temporarily say f inverse at a equals x so that I can easily do this. I can rewrite this using the original function. All right, I'm going to swap these around. So the original function at x should equal a. So f of x is the square root of 2x minus 1. So that means the square root of 2x minus 1 should equal a, which is 3. If I square both sides, the radical goes away, and we have 2x minus 1 is equal to 9. Adding 1 to both sides, we have 2x is equal to 10. Dividing by 2, we get x is equal to 5. We take that 5 and we plug it back in right here, and that is the end of step 1. Step 2 is we need to find f prime at the 5 that we just found. In order to do that, though, we will need f prime. So I'm going to rewrite this actually before I do f prime. I'm going to write f of x as 2x minus 1 to the 1/2 power. That's the same thing as the square root. Now I can find f prime using the chain rule. So taking the derivative of the outer function, I'm going to have 1/2. I'm subtracting 1 from 1/2, so that'll give me negative 1/2. And then I've got the inner function, which is the 2x minus 1. But when you have an inner function, you need to multiply by the derivative of the inner function for the chain rule. So the derivative of 2x minus 1 is just 2. Notice that we have 1/2 in the front and we're multiplying by 2 on the end. 1/2 times 2 is 1, so those basically cancel each other out. So now I have f prime at x is equal to 2x minus 1 to the negative 1/2 power. Just to make it a little easier to evaluate, understand that the negative 1/2 power drops this whole thing down to the denominator. So I would have 2x minus 1 now to the positive 1/2 power. But the 1/2 power is the square root. So actually, I'm going to put this as the square root of 2x minus 1. So this is f prime. Now, what did I say I was going to do? F prime at 5. So f prime, maybe I'll put another line. Okay, so f prime at 5 will be 1 over the square root of 2 times 5 minus 1. So f prime at 5 is going to equal 1 over the square root. 10 minus 1, of course, is 9. So f prime at 5 is equal to 1/3. So that is the end of step 2. Step 3 is trivial. Remember, we are supposed to evaluate the derivative of f inverse at a. But at this point, we can find that simply by doing the reciprocal of what we already have. So the reciprocal of this is 3, so that's the final answer. Let's see if we can do it again for a rational function. Remember, step 1 is to find f inverse at a. Now I will temporarily write f inverse at a is equal to x so that I can easily rewrite this using the original function f of x. In fact, remember that I'm just switching these values around. So f of x should equal a because that's how inverses work. F of x is x plus 6 over x minus 2. So that means that x plus 6 over x minus 2 should equal 3. Now it's a matter of solving this. So I'm going to multiply both sides by x minus 2. So this x minus 2 is going to end up right there. So we will have x plus 6 is equal to 3 times x minus 2. So now I have x plus 6 is equal to 3x minus 6. Let us subtract x from both sides. So then we get 6 is equal to 2x minus 6. Adding 6 to both sides, we get 12 is equal to 2x. Okay, and dividing both sides by 2, we get x is equal to 6. Let's take this and plug it back in right here. And that is the end of step 1. Step 2 is to evaluate f prime at the number we just found. In order to evaluate f prime, we need to find f prime. We are going to use the quotient rule to find f prime. So the quotient rule goes low d high, less high d low. Draw the line, and down below, the bottom squared will go. All right, I'm hoping this is not your first time hearing that little poem, but here it is again, one step at a time. Low d high. Low is x minus 2. D high means the derivative of the numerator. So the derivative is 1. All right, so this is low d high. Less just means subtraction. Now I need to do high d low. High is x plus 6. D low is the derivative of the denominator, which is just 1. So I have low d high less high d low. Draw the line, and down below, the bottom squared will go. So the bottom squared is x minus 2 squared. So this is the derivative, but I need to simplify it so I can evaluate. All right, I think I will leave x minus 2 squared the way it is. But in the numerator, I will have x minus 2. I'm distributing the negative sign, so this will be minus x minus 6. So I have f prime is equal to, okay, x minus x. So these just cancel each other out, actually. So those are gone. So we are left with negative 8. So remember, I need to evaluate this at the value that I found in the previous step. So I need to do f prime at 6. So that's going to be negative 8 over 6 minus 2 squared. So that's going to be negative 8 over, this is 4 squared, which is 16, which equals negative 1/2. So that is the end of step 2. And step 3 is trivial because to find the final answer, we just take the reciprocal of step 2. So the final answer is negative 2. Now looking back, I kept writing a. I have a here, and a here, and a is here. But we've known that a is 3 the entire time. So I think I'll replace these a's with the number 3. Okay, this is a better way to record our work. So on the next problem, I'll do that right from the start. Let's do it again with a trig function. Step 1 is to find f inverse at a. This time I'm going to put the actual number. So we need to find f inverse at 1. Okay, I'm going to temporarily put f inverse at 1 equals x until I rewrite this using the original function. So for the original function f of x, I can just sort of swap these around. So that would give me f of x is equal to 1. So now I need to solve this equation so I can have x. Let's see, f of x is cosine of 2x. Okay, so that's going to equal 1. So in order to solve this, I'm asking myself the cosine of what angle is equal to 1. I'm picturing the unit circle in my mind. You know, you wouldn't really draw this. But cosine is the x value on the unit circle, and the x value will be 1 right here. So this is an angle of 0. So I have just solved for 2x. Okay, I've solved for the stuff inside. 2x is equal to 0. And therefore x is equal to 0. I'm dividing both sides by 2. So I'm going to now take this 0 and plug it back in. So I now have, well, let me just do this. Bam! So that's the end of step 1. For step 2, I need to do f prime at the value that we just found. But if I'm going to evaluate f prime, I need to find f prime first. So I'm going to take the derivative of cosine of 2x. I'm going to use the chain rule. The derivative of cosine is negative sine. So I'm going to write that down first. Now, because we have this inner function of 2x, I need to multiply by the derivative of the inner function. So I'm multiplying by 2. So I like to put the 2 in the front, so I have f prime is equal to negative 2 sine 2x. So this is the derivative. I need to evaluate this at 0, right? That's what step 2 tells me. So I'm going to do f prime at 0, which will be negative 2 sine of 2 times 0. So f prime at 0 is going to equal negative 2 sine of 0. So what is sine of 0? On the unit circle, 0 is over here on the right-hand side. Sine is the y value, and the y value is 0 here. So the sine of 0 is 0. So we have f prime at 0 is equal to negative 2 times 0, which of course is 0. So f prime at 0 is 0. And that is the end of step 2. Uh-oh. I'm saying uh-oh because the final step is to find the reciprocal of this. Okay, so the derivative of f prime at a is undefined. All right, you can't take the reciprocal of 0 would be like 1 over 0. That is undefined. So actually, you can't say equals undefined, so I'm just going to say is undefined. All right, and that is the answer to number 4.